All right, welcome back to COMS 2014A, and this part is kind of practical number 2, and we'll be dealing about DNS interactions, right? So the quiz this time will be semi-technical, semi-theoretical, but then everything will happen in the quiz in Moodle. So it will be up to you to go and query something, and then you bring the answer on the quiz, right? So yeah, on the quiz in Moodle. We'll still have the GitHub type of submissions, but then it won't be for this time, right? I won't require you to bring me some code. All right, so as you remember in the lecture 5.2 about the DNS systems or the domain name systems, we were speaking about the DNS types, right? If you remember, we have some resource records. That's basically how a DNS database stores all the records in its DB, right? And then each resource record has a name, a value, a type, and a time to live, right? If you remember that very well. But then the name and the value are basically uh, managed by the type of basically of the type of the entry. Remember that if the type is A, remember that we have only the host name, right, and the IP address as value if that is the type A. We can have type 4A, which is the exact same thing, right, but then it's for IPv6. Type A is for IPv4, right? And I made a mistake in the video saying that IPv6 is 64 bits, but IPv6 is 128 bits. It's a longer type of email address. Sorry, it's a longer type of IP address, right? And then we have the type MX, which is this one, which maps to the mail transfer agents like the Gmail, the student.ac the student.vits.ac.za and stuff like that. And you have multiple other, you have the CNAME that has the alias one, like canonical name record, that for a particular domain name, right? And I'll put this website into the description below, and you can go and check this website, or you can type on Wikipedia list of DNS records type. That for the list of DNS record type. Now we'll go about querying some websites through the DNS server using our best known Wireshark. Let me close this Wireshark, and what I do, let me close this one, let me close that, let me close this. So what we do, we have Wireshark. I open Wireshark as admin, right? Because if I don't open that at admin, then I won't see my the network interfaces. I go for Wi-Fi. In your home, it can be Ethernet. In the university, it will be most probably Ethernet if you're using the computer in the lab. But then I'm using Wi-Fi because I'm on Wi-Fi. And as you can see, I'm having multiple queries going on in here, and I'm sure it's the same thing for your particular computer as well. Now we'll be dealing with DNS, and I'm sure you've seen some DNS here and there. But then first thing, DNS is a protocol, as you can see. TCP is a protocol, TCP/IP is a protocol. Right, you have the HTTP, which is a protocol as well, with port 80. You have HTTPS, which is a protocol with port 443. You have now DNS, which is also a protocol with port 53. DNS has a port 53. I'll write it somewhere as well for you. That's very important. DNS has the port 53. Now let's assume that we are here Okay, let's assume that I'm looking for anyone gives me a website. Okay, no one. Then I'll look for a website. A website we all know. It won't be Vits this time. Don't worry. I won't use that one. I'm using Vits a lot. But then it will be a university. Yeah, UKZN, like uh w www.ukzn.ac.za. Are we going to Durban this time through the internet? Okay, now we're going to the University of the KwaZulu-Natal. This is the university. We travel to Durban, right? We travel to Durban. Now, if I go to this Wireshark, there's a lot of packets that basically traveled, and then we will not be able to look for our UKZN website, right? So what we do, remember that DNS is a protocol, so we can type in here DNS. We have the DNS protocols, right? But then, even though we have the DNS protocols, right? The DNS protocols here, and you can see any DNS that I will just pick will have the port 53, right? Will have the port 53. That's one thing, right? And what I can also do that. I can type in DNS, but then I can type UD. I can type, okay, you see I'm doing that. I can type UDP dot port equal 53. Still fall under the DNS, right? Please remember that. I really hate typing notes in PDFs and stuff, but when I do, it's very messy, multiple errors and stuff. But I'll try to type stuff in the description. Okay, so we have the DNS that can either be in Wireshark DNS or UDP dot port 53. That will still give us DNS, but also it doesn't it gives us some things like that, right? And what I'll do, I'll then look for a UKZN. So unfortunately, I already loaded UKZN, right? UKZN is already loaded into my local cache. So what I'll do, you see UKZN, I'll put that on the next screen so you don't see it. And what I'll do, I'll just refresh that so that you guys can see what's going on here. All right, so let me refresh UKZN. You see that there's a little interaction that's going on, right? There's a little interaction that's going on here. Yeah, okay, if you remove Grammarly from the picture, there's this little interaction that's going on. Let's see if this one is the UKZN one. Is this UKZN? Let's see the query. Speaking about Google. That's not what I want. Let's type www.ukzn.ac.za. Okay. For some reason, it's not resolving that. No, it's not resolving ukzn.ac.za. Okay, all right. Let's try another website, another university website, because I already spoke about UP. Let's say up.ac.za. Oh yeah, UP came up, but why not UKZN? You see UP is coming up, and as you can see, I'm on the University of Pretoria website, and for some reason some LinkedIn are coming in. I guess they have some LinkedIn there, so you see that it pulls out every single thing it can. Now let's try takealot.com. So what we're looking at here, we're looking at some interaction that will go on at the bottom here, and you have to look for Takealot. I'm sure there are better ways of filtering with names, but whenever I get that, I'll let you know. But just look at here, and we're looking for Takealot. There we go. We have some Takealot, and you see that they come always in double, and one is the request, and one is the response or the reply. All right, so now we have take a lot. Oh, no, I'd rather have UP. UP, it's a university's website, and we go with universities. You don't want to buy stuff online. Okay, cool. So let's go with UP. Okay, let me stop, and then I run this again without saving, and then UP. All right, I have some responses here. Okay, so you see we have this one and that one. All right, so let's see. Why is this things are sometimes www.up.ac.za. Okay, UP is not coming. Obviously, it's been cached already. Let's see, because it's been cached, it can just return the response as quick as possible, and that's obvious. And I don't want to go and clear the cache. Okay, let's try with www.uct.ac.za. So this is the University of Cape Town. And what I'll do, I'll stop this one. Let me run another one, and we'll go with UCT. And there we go. We have uct.ac.za, and as you can see, we have the UCT that looks like this here, but it's UCT website. And now let's examine, or let's check the UCT reply and the UCT response. Okay, now if you see what you can do now, you can say, okay, you can see that the UCT request, we have one question. What is the UCT basically IP address? And then we have a response somewhere in package number 12. And you can see that the query as hosted is that we have the UCT website, we have the type, and then we have the class. The class is out of this scope, but you can go and query about that, right? But then we have UCT, we have the type, and the type says that it comes with this IP address, right? So what we will do, since this one has a transaction ID, remember this is a DB, right? And you remember the format of a request or a reply, right? This is actually the format. We have the question, we actually have one query, right? Which is the name, and which is the name, and the IP address will be resolved, right? And then we have the transaction ID. And now let me apply it as a filter, right? I just apply that as a filter. When I apply, like I right click on the transaction ID, right? And I apply it as a filter, I click on selected. And when I do that, you would see that the packet number 12, where basically the response actually stays, right? The packet number 12, where the response actually stays, right? It's basically here. It's like saying that, okay, that's basically that, isn't it? All right. So what we have, we either we can go to packet number 12, or we can just come here, right? If we click on packet number 12, we have the query, and then we have the answer. We have the answer as uct.ac.za. This is our question. That's the question. Now that's basically a canonical name, right? That's basically a normal host name. The canonical name is the whole of this thing, ecm.vip dot, I guess it's production dot uct.ac.za. In fact, let's just copy the value, and I'll paste it right here, and let's try to resolve that, and we get to some sort of dashboard here that belongs to UCT, and I guess it's for some admin guys. Please guys, Do not go and hack anyone's computer because of this particular code. This is a disclaimer. Do not go and hack anyone using those. These are powerful tools, and it needs to be used with great responsibilities. Great powers come with great responsibilities. All right. So now we have the canonical name that's of type A, and since it's of type A, then we have the IP address of UCT, and we can still go ahead and try to paste this one in here, and obviously we're still getting the same dashboard. I guess that particular website, it's just for getting into the internals of that. But then this is the UCT name that you wanted, and the DNS server says that okay, you're looking for the page, because when you say uct.ac.za, it has a page at the end. It has / index.html. That's basically what you're looking for. But then this one is like, yeah, an admin page or some sort, and you basically have the request, which is in packet 11, that you can still get in our packet 11 right here, right? And our packet 11, we have our creation, and we basically have one response. We basically have one answer here, right? That's exactly what we get. And the other parts are what you saw in the previous practicals, and it was basically very easy for you, right? Yes, that's basically that. So this is the resolution, and those are within South Africa, right? So if I close this one and then I run a new one again, and I have been speaking about YouTube a lot. So if I'm going to oh, I forgot that I brought this one on the next screen. So if I bring maybe www.youtube.com, or let's say what other website, let's say www dot, I don't know, not YouTube, let's say Yahoo, yeah, Yahoo dot fr, that's in France. Okay, so let's try this one. You see, I typed in yahoo.fr, and then it directs me in France. Don't worry, this is French that I understand perfectly, but then I took that for a specific reason. All right. Okay, here we have nothing, because I mean, obviously we do not have any ID. We do not have anything of this ID, and we can type in here DNS. Yeah, and you see here we have Yahoo, we have fr.yahoo.com, right? This is basically the DN, like this one, I guess, the packet, the request. Oh yeah, this is it. This is where the request is. This is a request. Haha. Now what we do, since I have the request here, and you see that it has request ID, right? I double click on here, and oh, I can just click on that, right? And then I'm saying, okay, just give me everything DNS with ID, which is equals to 0x8c0f. All right. Okay, so this is what we've got, right? So we have the DNS query from yahoo.fr, right? And then this is the query, this is the response, right? The query is obviously we want to know about yahoo.fr, right? We have one question, and the response is in packet 347. All right, so we have one question, right? And we have 5 answers. Haha. Remember, these are numbers, and the numbers, the things are here. This is what we have. We have 5 different servers with the same type, with the same class, but then we have different IP addresses, and those different IP addresses are located in different sides of the world, right? They are not at a single location. So if I do, for example, I come here, say ping www.yahoo.fr, and then I'll be having this 212. I have exactly that. You see that? Same thing. It decided to go for that particular server, right? Let's try another time. Okay, that's the closest server to me, right? That's basically the closest one. And if I do an IP lookup, right? If I'm doing here an IP lookup to see basically where that server is, I will let you know now. So I just type any IP lookup server. So the internet service provider of this one is in the United Kingdom, right? So if I type in the second, or let's say the first one, 106.10.248.150, then let's check. This one is in Singapore, right? And let's try the very last IP address, 98.136.103.23. And then let's look at this particular IP address. Oh, my bad. Oh yeah, I can see I put in 2 dots. Let's see, this IP address is located in North America. You see that all these IP addresses, it returns 5 responses, but then it gives you the closest server for you, right? The closest server for you for that particular website. So if I stop this running server, and then this is the very last example, and then I type in here DNS, right? And I basically go for instance, now we go for a South African website, www. Let's say, well, that's strange. I don't know any South African website. Take a lot. Let's say takealot.com, right? Takealot.com, and then gives me some sort of promotion and stuff like that. Let's see where Takealot. Let's start capturing, and let's refresh Takealot. Okay, Takealot's being refreshed, and does it give me anything here about Takealot? I think we have 9 responses. Is that about Takealot? And you see that, all right. So you have nice instances of what we call canonical name, right? These are canonical name, and I'm sure Takealot has its servers in different part of the world. That's the reason why we have multiple canonical names. All right. So if I go, let's try again to hit takealot.com, just for the fun of it. So we're here on that. Let's hit takealot.com. All right. Okay. So we have multiple lines here for this, and then it gives us a lot of response. Unfortunately, I think the name of Takealot is well hidden somewhere, and then I wouldn't want to just dig into here because I wouldn't want to get to understand the canonical name of everything here. Obviously, Takealot is hidden within the what we call EC2 or Elastic Cloud Compute. It's a service of Amazon that basically hosts a server, and I'm sure one of these things it's Takealot, and I'm very sure about that. So if these are responses, right? Let's say this request, I'm sure this is an ad. Okay, I wouldn't want to fight over take a lot. Apparently they don't own a specific server to them, so I don't want to fight with that. Let's look for another one. fnb.co.za. Let's see. We have these ads. Oh, online FNB, haha. Online fnb.co.za. So DNS, where again, please guys, do not go and start hacking anyone there on the network. 7C2. So what I say, go and look for the DNS request or the DNS set of packets where the DNS ID is equals to this one. All right. So we have our response here, and as you can see, let me kill all the answers. So as you can see, we have 4 answers, and we have 4 answers. Based on those 4 answers are at different locations. Obviously, they are still within South Africa, right? But they are even still within the same server. They are still within the not the server, but they are still within the same location even. But then they call different server. And I'm sure if I'm going to here again, www.fnb.co.za. My bad, I forgot about Bing. Okay, so I'm in a 149 and I'm sure it's located to another different server, but then it's still 196.11.125, 196.11.125. But then they have, in other words, they have multiple different servers. Okay, so guys, this is basically the that was a fun practical for me. I really hope that you enjoy this particular practical. I'll try to get you questions about all of these exercises and make sure that the answers that you provide are as general as possible so that you don't fail on an answer that worked for me. Again, good luck and enjoy this particular side of the lecture. Bye.